Bismillahirrahmanirrahim. Students, welcome to virtual session of week 10 of IT Project Management course. If you can listen to me properly, please raise your hand. Okay, thank you. Okay, so now I'm going to continue from my lecture, which I was giving in my face-to-face class. So let me upload the slides first. Can you see the slides? Okay. So in our face-to-face class, we were talking about project quality management. And since quality is one of the very important factors which is important for the success and failure of a project, so the management of quality is very important. And I told you that there are some processes involved in project quality management, which are planning the quality, then performing quality assurance, and then performing quality control. Now I'm going to skip the slides which I've already covered in class, and I'm going to the one which I left. Okay, from here. So we were talking about quality, and I told you that there are different quality systems or quality tools and techniques which we can use to measure quality or to assure quality. So Six Sigma is one of the standard or principle, you can say, which is designed by experts to improve quality and to decrease cost and to meet the customer needs. So it is a comprehensive and flexible system for achieving, sustaining, and then maximizing business success. So first of all, you achieve success, then you sustain it, maintain it, and then you maximize it. Six Sigma is uniquely driven by close understanding of customer needs, disciplined use of facts and data and statistical analysis, and diligent attention to managing, improving, and reinventing business processes. So this is it's all about. Now the target of perfection is the achievement of no more than 3.4 defects per million opportunities. So in any area you can use it. You can use Six Sigma in any of the process. So you may be using it in any area, but the requirement is that, like in per million opportunities, there should be no more than 3.4 defects. So this is what it says. The principle can be applied to a wide variety of processes, and it can be applied to the designing activity, or it can be applied to a production of products, or it can be applied to a customer service process, or any process. So for any process, we are saying that no more than 3.4 defects per million opportunities. The Six Sigma project normally follows a 5-phase improvement process, which is called DMAIC. So the 5-phase improvement process, like if the projects are following the Six Sigma principles, then they will follow this 5-phase process. Now what does DMAIC stands for? D stands for define, M stands for measure, A for analyze, I for improve, and C for control. So this is DMAIC, which is pronounced DMAIC. DMAIC is a systematic closed-loop process for continued improvement that is scientific and fact-based. So when you say define, so it means define the problem, opportunity, process, and customer requirements. When you say measure, define measures, then collect, compile, and display data. When you say analyze, it means you perform scrutinization process. Detail is to find the improvement opportunities. So by scrutinizing, you means like you investigate and verify the data, and you identify the root cause of those problems. And when you find the root cause, you can use different methods to identify the root cause. You can use the cause-effect diagram as well. So when you identify the root causes, then you find the opportunities for improvement. So this is what analysis phase does. The fourth one is improve. You generate solutions and ideas for improving the problem. You find you find solutions for improvement. So you get those solutions verified by the project sponsors, and your Six Sigma team also sometimes check whether their solutions are okay or not. Then comes the control process, which is about tracking and verifying the stability of the improvements and predictability of the solution. Like you want to check using some control charts or some other ways that whether the improvements made are permanent, or they are stable, or they are temporary. So you control as well. So whenever a process is following these 5 sub-processes DMAIC, then it will be based on the Six Sigma principles. Now, how is Six Sigma quality control unique? So, although there have been many quality initiatives from in past before Six Sigma, and like the people were going for total quality management or business process reengineering, and said there are some solutions to improve quality. So these are the past. And now the Six Sigma is taking up many things from the past, but there are several new ideas in this as well. Now, how Six Sigma work is, like it requires an organization-wide commitment. So it's not only for a process or for only a project, it requires an organization to go for it, and its training follows the belt system. Where belt system is like the one of the karate. Like when students go in a karate class and they perform, they get different color belts as per the training level. So here as well in Six Sigma trainings, the organization has different belts, and then the different people or different processes are placed in different categories of the belts. Like some get yellow belts, some get red belts, some get green belts, some get black belts. So project managers are often black belts. And Six Sigma organizations have the ability and willingness to adopt contrary objectives such as reducing errors and getting things done faster. So now, since your organization is going for it and your organization has adopted for this system, so the organization will take initiative to adopt these contrary objectives for reducing errors and then getting things done faster. And how this Six Sigma is unique, another reason is that it is an operating philosophy that is customer focused and strives to drive out waste, raise levels of quality, and improve financial performance at breakthrough levels. So in Six Sigma organization, we set high goals and we use the DMAIC improvement process to have better quality. So the organization will be going for it. Motorola pioneered the adoption of Six Sigma in 1980s and saved about $14 billion. And Allied Signal Honeywell saved more than $600 million a year by reducing the cost of rework defects and improving aircraft engine design processes. So the organizations which are going for Six Sigma, in fact, reduce their cost, and they have minimum defects because their processes are stable. Now Six Sigma and project management. Joseph M. Duran stated, all improvements take place project by project and in no other way. It's important to select projects carefully and apply higher quality when it makes sense. Companies that use Six Sigma do not always boost their stock values. So stock values, so choice of project is also very important besides Six Sigma. So once a project is selected, you have carefully selected a project, then now these techniques can be Six Sigma techniques and processes can be applied to them, which will ultimately reduce the cost and remove the number of defects. Six Sigma projects used project management. The training for Six Sigma includes many project management concepts, tools, and techniques, which you are studying over here. For example, Six Sigma projects often use business cases, project charters, schedules, budgets, and so on, which we are already developing over here. And Six Sigma projects are done in teams. The project manager is often called the team leader, and the sponsor is called the champion. So Six Sigma projects are not much different from the normal projects which we are developing, but we are paying more attention to the quality. Now Six Sigma and statistics. The term sigma means standard deviation. So here comes the word of Six Sigma. Six Sigma, we improve quality in Six Sigma by reducing variation. Now what standard deviation does is, standard deviation measures how much variation exists in a distribution of data. Small standard deviation value means that the data clusters closely around the middle and there is a little variability among data. And a large standard deviation means the data is spread out around the middle of the distribution and there is a relatively greater variability. So this sigma signal is used to represent standard deviation, and the standard deviation is a key factor in determining the acceptable number of defective units found in the population. Six Sigma projects strive for no more than 3.4, as we have already talked about. Six Sigma uses a conversion table. I told you that we are going for standard deviation. Now, what we do is that in Six Sigma, if you have studied statistics, you will be familiar with the normal distribution curve, which is a bell-shaped curve that is symmetrical regarding the mean or average value of the population. Now, using the normal distribution curve, if a process is at Six Sigma, there will be no more than 2 defective units per billion produced. And Six Sigma uses a scoring system that accounts for time, an important factor in determining process variation. Yields represent the number of units handled correctly through the process, and defect is any instance where the product or service fails to complete the requirement. And this is the normal distribution curve, where mean lies at the center. And this is the Six Sigma conversion table, Sigma 1, Sigma 2, 3, and up till 6. You can see here, if defects per million opportunities are 3.4, then your organization is at 6 Sigma. If it is 230, it's 5 Sigma. If 4, it's 6,210, it's 4 Sigma. And if 6,90,000, it's 1 Sigma. And what this yield is represents the number of units handled correctly through the process steps. If 30.1% are handled correctly and the defects per million are this much, then it is 1 Sigma. And if 99.99% are handled correctly and 3.4 defects, then it is at 6 Sigma. Now comes 6 nines of quality. 6 nines of quality is a measure of quality control equal to one fault in 1 million opportunities. This is another term which is used in the normally in the telecommunication industry, is fixed nines. So it means 99.9999% service availability or 30 seconds of downtime a year. This level of quality has also been stated as the target goal for the number of errors in a communication circuit, system failure, or errors in line of code. But it's far away to be met. To achieve fixed lines quality requires continual testing to find and eliminate errors or having enough redundancy or backup equipment in the system. So it's a very high standard to achieve. Now comes the next topics of testing. Many IT professionals think of testing as a stage that comes near the end of IT product development. But it's not true. Testing should be done during almost every phase of the IT product development life cycle. This is not the last step. Now, testing task in software development life cycle appears like this. Now, this figure is very, very small. I hope you can see this. Now, you can see here the first step is initiate project, then feasibility, then project planning. Here you can see that in the development, you are performing unit design and coding, and then unit testing, integration testing, system testing, acceptance testing. There are different forms of testing which are being performed. Now, what these testings are? Unit testing tests each individual component or a program to ensure that it is as defect-free as possible. And integration testing occurs between unit and system testing to test functionality of functionally grouped components. So when you are integrating different components, then you perform integration testing. System testing tests the entire system as one entity instead of testing each unit. User acceptance testing is an independent test performed by end users prior to accepting the delivered systems. The user will perform testing before accepting that system. Versus Humphrey, a renowned expert in software quality, defines a software defect as anything that must be changed before delivery of the program. Testing does not sufficiently prevent software defects because the number of ways to test a complex system is huge, and user will continue to invent new ways to do the system. So he suggests that people rethink the software development process to provide no potential defects when you enter system testing, and developer must be responsible for providing error-free code at each stage of testing. So these are the view that the user should be provided error-free software. Now the modern quality management is a little bit different, and it requires customer satisfaction. We are now treating modern quality management in a different way, and we say that the customer satisfaction is more important. It prefers prevention to inspection. Instead of performing inspection afterwards, it is better to prevent. Recognize management responsibility for quality, and noteworthy quality experts including Deming, Uren, and they have proposed this, that they have proposed these 14 points for management, in which they have stated that the modern quality management should put more responsibility on the management for this. Now this is a book which he has mentioned. The Malcolm Baldrige National Quality Award originated in 1987 to recognize companies that have achieved the level of world-class competition through quality management. And this award is given by the President of the United States to U.S. businesses. And there are 3 awards each year in different categories: in manufacturing, in service, in small business, in education, and healthcare. So they have introduced this award so that the organizations who are going for quality should be encouraged. Now comes the ISO standards. ISO 9000 is a quality system standard, which is a Okay, before going into the details of this ISO standards, I want to tell you that you have to read some stories or some concepts mentioned about this modern quality management in your textbook, because on the few details are mentioned in the slide, you have to go to read these details from book. Now, ISO now is a quality system standards that is a three-part continuous cycle of planning, controlling, and documenting quality in an organization. It provides minimum requirements needed for an organization to meet its quality certification standards. So we can say that like this standard defines the minimum requirements for our organization to meet to get this certification. So if you ISO 9000 family of international quality management standards, they have different standards for different type of products and processes. Now there are some suggestions given in the book for improving information technology projects quality. First of all, the one suggestion is to establish leadership that promotes quality, understand the cost of quality, focus on organizational influences and workplace factors that affect quality, and then also go for some maturity models. Now if we focus on each of these steps, so since first suggestion is to establish leadership that promotes quality. So the leadership who is going for quality, who is not compromising on the quality, will ultimately make his team deliver the quality product. Then understanding the cost of quality is important. It means the cost for delivering the product, meeting the requirements, and the cost of taking the responsibility for failures for not meeting the quality expectations. So if you are including both of these in cost of quality, so this is cost of quality. Like you are not only responsible for, or not only bearing the cost for meeting the requirements, but also the cost of not meeting the requirements. That is called cost of non-conformance. So the cost of conformance and cost of non-conformance both are equally important. The third factor is focus on organizational influences and workplace factors. So this is also a very important factor, because there are certain workplace factors which can influence the quality as well, as they have proposed in based on some examples, or they have stated because of examples, that if the organization is having some factors which are influencing the quality measures of quality parameters cannot be achieved. And then going for I hope this point is clear, like organizational influences and workplace factors that affect quality. Because when you are developing a product, your organization contains different types of people who are belonging to different nations or different cultures. So their expectations about quality may be different, or their definition of quality may be different. So you have to cater for those differences, and you have to ensure that the product which you develop is as per quality according to the requirements. Then you can improve quality if you follow some maturity models as well. Now, what maturity model is? It is basically a framework to help your organization to improve the process and business. There are different maturity models which were proposed, and some of the popular maturity models are CMMI. Previously it was called CMM, Capability Maturity Model, and now it is called Capability Maturity Model Integration, and there is called another software quality function deployment, and some other models as well. So first of all, it is important that you follow some capability maturity model as well to deliver the product. The cost is, now I explained these points in the previous slide. So the costs include prevention cost, appraisal cost, the cost of evaluating internal failure cost, external failure, and equipment cost. And these are some of the environment factors which I've already talked about. The geographic regions, organizations, culture. And the maturity models are frameworks for helping organizations improve their processes and systems. And there are some software quality functional deployment model and capability maturity model as well, which I have also talked about. Now, the CMMI model, capability maturity model integration, has different levels. The first level is called incomplete. Now, the lowest one is shown at the top. The lowest level is incomplete. The second is performed. Third is managed. Fourth is defined. Fifth is quantitatively managed. And the sixth is optimizing. Now, these are numbers from 1 to 6. The level 1 is incomplete. 2 is performed. The companies may not get to bid on government projects unless they have a CMM level 3. And how we select this CMM level 3? The organizations have to pass through the appraisal phase to get a ranking, so where the organization stands. PMI released the organizational project management model in December 2003. Model based on market research surveys sent to more than 30,000 project management professionals, and it addresses standards for excellence in project program and portfolio management. OPM3 provides the following example to illustrate a best practice. Best practice is to establish internal project management communities, capabilities, facilitate project management activities. Outcome is local initiatives, meaning the organization develops pockets of incentives and areas of special interest. And there are some KPIs, which are key performance indicators, and the community addresses local issues in that case. You can use software to assist in quality management. You can use the spreadsheet and charting software. You can use statistical packages, or you can use specialized software products developed for Six Sigma projects. You can use Gantt charts and other tools to track the record of your project as well. So the project quality management ensures that the project will satisfy the needs for which it was undertaken, and the main process includes our plan quality, perform quality assurance, and perform quality control. Okay, these are the topics which we had to talk about today. So the contents ends over here. If you have any question about these, you can ask me now. Any questions? Okay. Okay, any other question about any previous lecture or this week? Anything you want to ask? Okay, so now this week was about project quality management, and this was week 10. In week 11, we'll be talking about project human resource management. So that will be a very interesting topic. In this week, we have talked about project quality management. I want you to read the relevant text from your textbook because the complete chapter is included, and also see the supporting material available over the blackboard for this week. And I hope you'll be asking me some questions in our next face-to-face class about this. Okay, thank you very much as well. I'm closing the slides and I'm turning my microphone off. If you have any questions, you can ask me in the chat panel. Okay, thank you very much.